All right. Let's fade that out. Okay. Good afternoon, evening, something or other. Let's bring in a fancy title screen. Cut over to me and say hello. Hey, folks. One more time feeling. Now we've got all the connections wired up. We're starting out a new set of best of streams from PACSEC and CanSec West, and we're going to be sprinkling in some new material from our training courses. We're trying to pivot PACSEC, which was a conference we do in Japanese and English, into an online format, which, as far as I know, no one's done a multilingual computer security conference yet. So we're going to be brazenly break new ground there and try to figure out if we can do this with translation. We're also, since we're going to go the trouble of translation, we're going to go one step beyond that and say, if we get 100 tickets from any particular demographic, be it Spanish, Chinese, German, whatever, we'll try to set up more than one simultaneous translation at the same time and try to get material as multilingual as possible. Because about 100 tickets is what's going to cover the cost of the interpretation and translation that we've seen so far. So it's kind of up to you, Internet. If you would like to have an international conference, come join us at PACSEC. We're pulling together some pretty interesting panels that we're going to be trickling out. And you're going to be hearing more of that information over the coming weeks as we're going to try to make this a regular broadcast. So without much ado, for the very first time here, we were going to play back one of the conference sessions from CanSec West, which, as some of you may remember, we had to pivot very quickly because the city of Vancouver shut down the day we started it. So we are planning for an ever-decreasing number of people as the pandemic started to roll out. And it turned out into a completely virtual conference. So we had some pretty good presentations, one of which that stood out was this one because it's very topical about deepfakes from Mengyun Tan from Tencent. So without further ado, let's cut to that. And you folks can watch some of her very fascinating work about using AI to defend and attack humans with their perceptions. So here's Mengyun Tan.
I'm a security researcher from Tencent. This year is really a crazy year for us. Sadly, I cannot go to Canada to be together with all of you, but still luckily we can connect via this remote conference. Today, I'm going to talk about the risk of AI abuse towards deepfake attacks and defenses. Before I start it, I want to introduce ourselves first. I am from AI Security Lab of Tencent Security Platform Department. And Tencent Security Platform Department has been dedicated to the protection of QQ, WeChat, Tencent Games, and some other critical products, and focus on Tencent account security, AI security, anti-fraud, anti-scamming, intrusion detection, mobile app security, and some others. We built Tencent Tianmu, a system to automatically prevent network intrusion. And other products include the Tencent Security Response Center, Tencent InstaView, Horrors, Antifix, and some others. Okay, let's come back to the topic. In this presentation, I want to discuss existing AI security problems first, and then I'm going to talk about the risk of AI abuse. That is, if we use AI in a bad way, what will happen, such as deepfake attacks. After that, I will introduce what is deepfake and how to prevent the abuse of deepfake. At the last, I want to share a little story about how we use AI to try some good things. I think everyone here has heard how incredible, powerful, and successful AI is. Many different tasks that could not be solved with software before are now solvable thanks to deep learning and neural networks and gradient descent. All of those technologies that are working really well, we call them AI. Today, AI is around us every second of the day. AI with medical, for example, giving a large amount of medical images, AI can help doctors to detect and recognize whether there is a cancer or some other diseases. AI and education enables more and more students to study some online courses at home to improve themselves. But let's think AI from the point of security. Is AI safe enough? Definitely the answer is no. There have been some security problems challenge AI. The first, software and hardware security problem. That is, there may be some vulnerabilities in the software and the hardware that used to deploy AI systems, including deep learning frameworks, gradient graphic processing units, and some others. Second, the robustness of AI models. We have proved that AI systems based on deep learning are easy to be deceived. It maybe cannot give correct predictions of some specially generated examples because the parameters of an AI model are limited. And model security is also a hot field to be discussed in AI security. In most cases, providers of the AI models only want users to use the query service of those AI models, but don't want to expose their trained models. However, attackers maybe can steal the model while multiple queries. Besides, at the data level, if the training data is mixed with some malicious examples, it may affect the robustness of AI models. So data security and data privacy challenge AI as well. There has been many attacks against AI systems, such as adversarial attacks. I have given a talk about the adversarial attacks named adversarial example using AI to cheat AI last year. We point out that AI systems based on deep learning are vulnerable to adversarial examples. And an adversarial example is an example that we apply some small perturbation on, and then making the prediction of the neural network change to another incorrect label. As this figure shows, in this case, we change the image of a pendle to cocktail shaker. And for most cases, such modification on images usually cannot be noticed by human eyes. Actually, adversarial attacks have generalized to the physical world. It is possible to create perturbations on physical objects to fool the deep neural networks, even under a variety of real-world conditions, such as distance change, wrapping, deformation, and native effects of the light and print. We also conducted some experiments about physical adversarial attacks. We generate a physical patch to full object detection network. For object detection network, it usually takes in an image and then outputs the detected objects and their coordinates and corresponding labels. Okay, let's watch a short video. At the beginning, there are two cars in the video, and we use an object detector to detect the objects in this screen. Here we can see there are the object detection network can correctly detect those two cars. And then we put our physical patch on the gray car, and the bounding box of it disappeared. That means the object detection network cannot detect the gray car anymore. Next, we move the patch from the gray car to the white one. The bounding box of the gray car reappeared, but the bounding box of the white car disappeared. That is, the object detection network can correctly detect the gray car again, but cannot detect the white one. At last, for a comparison, we put a patch of random noise to the gray car at the end, but the object detection network still can detect it. The experiment indicates that a specially generated physical patch can fool deep neural networks. It also poses a risk to deep learning modules used in safety-critical cyber physical systems. Moreover, adversarial attacks also in the audio domain, giving any waveform, adding some small perturbations on it will make the result transcribe as any desired target face. Backdoor attack is another popular attack against AI systems. It aims to manipulate a subset of training data by injecting adversarial triggers, such that the deep learning models trained on such tempered dataset will make targeted incorrect predictions on the examples with the same triggers. That figure shows an example of the backdoor attack on federated learning. Typically, the performance of an AI model significantly relies on the amount of the data. A good choice to achieve a robust enough model is to train the model on a combination of data from different groups, but in most cases, those groups don't want to share their data and put them together. So federated learning was proposed to address this problem. It can use local training data sets of different participants to train a shared global model with improved performance. But with the limited access to the individual data makes it is possible that once a participant poisons their data, the shared model trained with federated learning will be attacked. Model stealing attacks. As you know, various AI services are available on cloud, and within the data it outputs the prediction results. Image classification, for example, within an image to query the AI service, then it outputs the label and its corresponding confidence. However, based on that, attackers may utilize the outputs of multiple queries as a target loss to retrain a new model that is similar to the one provided by the AI service and achieve the purpose of model stealing. In general, before an AI system to be used, it will go through many processes, including data preparation, model training, and model deployment. Each process may be attacked by attackers. For example, we should defend against data poisoning attacks, adversarial attacks, and backdoor attacks while we preparing the data. And to defend against model stealing attacks while we use the AI models. So that security is still one of the biggest challenges in deploying AI systems. And in each stage, we should take corresponding measures to prevent attacks. Okay, I have discussed the existing security problems of AI. Let's think more. Is there any other risks of AI? Think about the question, what will happen when AI out of control? Machine intelligence surpass human in all round way like this? don't worry, machine intelligence is still very far beyond humans. And this is the truth.
Tell them if they like this video to go to corridordigital.store and check out our sweet merchandise. Show them the sweater. Show them the sweater. This is brand new.
So what is the immediate concern about AI out of control? Actually, it seems to be dangerous for Hollywood and Bollywood actors, as they may find themselves muffled into porn videos. Just like this one, somebody created a fake porn video that featured Gal Gadot, yes, the Wonder Woman, using an AI-powered app. This video was posted on a Reddit community called Deepfake. To be honest, it's difficult to tell that if the video is a fake video or real. Since then, so emerged many deepfake videos that have been tempered by AI technicals. This problem led us to think about the risk of AI abuse. In fact, manipulating video is nothing new. Actor Paul Walker died while 2015's Fusion 7 was in production. To finish this film, filmmakers shot the actor's brother and digitally inserted a compost of Walker's face. It's been possible to alter video footage for decades, but doing it took time and highly skilled artists and a lot of money. However, deepfake technologies could change the game. As it develops and proliferates, anyone could have the ability to make a convincing fake video. In ancient time, people used drawings to record events. In last thousands of years, only hundreds of drawings are created, but now we use audios and videos to record our lives, and massive amounts of videos are being produced every day. Audios and videos record our history, and we usually assume they equal reality. So what is going to happen when deepfake reality? The first, I think, is about the deepfake rumor. Deepfake is highly likely to be a tool for making fake news. If those fake videos and fake audios with some wrong information are posted on the internet, no doubt this will accelerate the spread of the online rumors. And deepfake pornography is by far the most prevalent kind of deepfake currently being created and circulated. About 96% of deepfake videos are pornographic, and the damaging effects of deepfake pornography have already affected a significant number of women, including some celebrities and private individuals. Besides, there have been several reported cases where deepfake audios have been used to defraud the companies. As this news said, fraudsters used AI to mimic CEOs' voice to defraud. And this case illustrates how deepfake audios could be used to enhance existing fraud practice against the business and individuals. Besides, deepfake has had a disruptive impact on political areas. There have been many deepfake videos targeting political figures and try to modify their speech to create a political crisis. What's more, deepfake is possible to be used to manipulate the elections. What I mentioned above are broader risks about the abuse of deepfake. In fact, machine intelligence supports human beings in all-round way is still far away, but we should pay attention to the immediate concern. The same AI technicals can be used to benefit mankind, but it also can be used to destroy the society. What if when our seeing and the listening is no longer believing? I think that's a question is worthwhile to sort out. The next, what is deepfake? Deepfake is an AI-based technology that's used to produce or let video content so that it presents something that didn't in fact occur. The word applies to both the technologies and the video created with it. It is a combination of deep learning and fake. There have various different algorithms for creating deepfakes. Face-to-face is an early method which was proposed in 1916. It is a real-time treatment that can work with a standard webcam. But it is just an expression-only method, just replace the movements in the face of the target video by the source face. That means the texture of the target face is same as before. This figure shows the pipeline how to use face-to-face to deepfake a new face. It first reconstructs the shape identity of the target actor using a global non-rigid model based on bundling approach. At the runtime, it takes both the expressions of the source and the target actor's video. And for the final image synthesis, it re-renders the target's face with transferred expression and composed it with the target video's background. Finally, they introduce a new image-based mouse synthesis approach to generate a realistic mouse. Generative adversarial networks have been widely used to generate deepfake videos as well. Due to its flexible applications and realistic outputs, such as deepfake, cycle-GAN, recycle-GAN, and some others. Unlike the expression-only face reenactment, GAN-based methods actually morph a person's face to mimic someone else's features and preserving the original face's expression. That means the texture of the deepfake face is much more similar to the target face, but the facial expression is much more similar to the original one. It takes several steps to successfully swap a face. First, two alter encoders are trained to reproduce those two faces of both person A and person B, as this figure shows. After the two alter encoders can reproduce the face A and B respectively, the next step is to actually swap the faces. This means providing the decoder for face A and with a compressed representation of face B. Decoder A will convert this representation into the face of person A along with the facial expression of person B. That means the final generated face B is much more similar with the face A, but the expression of the generated face is much more similar to the face B. And GAN-based deepfake method usually requires hundreds of pictures of the source and the target faces. And the training process often takes several hours and more than 10 hours. Besides, they have imagined some apps to create deepfake videos. The first one is DeepNet. This app uses deep learning image translation algorithms to remove clothes from the image of women and then generate naked parts of their body. And another case is Zao. This is an entertainment app. It turns a user's face into the face of an actor or an actress in movies or TV series. Everybody can be a famous actor just like Hollywood.
I got some troubles, but they won't last. I'm gonna lay right down here in the grass. And pretty soon all my troubles will pass, 'cause I'm in shoo.
In this video, Marilyn Monroe's face swapped to my face. Amazing, you know, Monroe is my favorite actress. Actually, face swapping appeared in China long ago. That is the face swapping of Sichuan opera. This is a kind of Chinese traditional art. Let's watch a video. In this video, the actor rapidly switched his masks. In fact, now we have another modern tech art face swapping using AI. Okay, welcome to my deepfake show.
And systems are a go.
No any props required, just a photo of the mask face and a compute. We can swap your face to anyone you want. So how we achieve it? This figure shows the pipeline of our method. At the beginning, we have a source image. That is the image you are going to change the face, and this is a photo of mine. And we also have a we also have a target image. This is an image. This is the face you want to swap to. First, we use facial landmark detection algorithms to detect the landmarks of those two images, and then we use 3D face modeling technologies to capture the textual information of the target face and the pose information of the source one. After that, we can reconstruct the target face according to the pose and the expressions of the source face. We call this reconstructed face is a render face. We also use some image processing algorithms to correct the face color of the render face. Meanwhile, we use semantic segmentation algorithms to segment the face region of the source face. At the end, we blend the render face to the face region of the source image. A fake image is produced. Our method consists of 5 main modules. Let's see more details. The first module is facial landmark detection. It aims to automatically localize a group of predefined points on human faces, such as eye corners, mouth corners, and some other points. Here we detect 68 special points. This module includes 2 steps. The first is to use a face detection network to get the coordinates of the face. Then we crop the face according to the coordinates and feed it to another landmark detection network to get its landmarks. Here, make a note. In the later presentation, I will show a lot of network architectures like those two pictures. They are all AI algorithms based on deep learning. You can regard them as different combinations of predefined operators, such as convolutional, max pooling, batch normalization, and so on. And if you, with any knowledge of the deep learning, you can just consider them you can just consider them as modules to implement different tasks, such as image classification, face detection, and so on. The second module is 3D modeling. This is most significant part of our method. Given the facial landmarks received by the previous step, we can get the pitch, yaw, and roll angles of the face. And then we use a candid 3D model to quickly reconstruct the target face. This is a lightweight enough 3D face reconstruction model. The pose and the expressions, and finally the pose and the expressions of the generated face will be similar to the source image, but its texture is similar to the target one. Those pictures shows 3D modeling results of different inputs. The next module is face segmentation. That is to use a semantic segmentation network to segment face region at the pixel level. As this figure shows, semantic segmentation includes category prediction and pixel-wise labeling. We feed an image into the network. It will output pixel-wise labeled instance and corresponding categories. And this step is prepared for the face splitting, because in some cases, the face regions of two faces are usually different. Face color transfer is to simply use image processing algorithms to reduce the differences in the skin color between two faces. Look at this case. If I swap the little girl's face to my own without the face color transfer, what will happen? Well, like that, the generated face has different skin colors, dark in the middle and light on the edges. But after the face color transfer, it's like this. I think the later one is much more cute. The last module is face blending, and this figure shows the hue process of it. This module is to use Poisson fusion algorithms to blend the reconstructed target face to the face area of the source image according to different face. At the center of the face, the weight of the render face is larger than each of the source face, but in the edge area of the face, the weight of the source image is larger. After those steps, we could get our deepfake result. Here you can see 3 images. This is the target image, the face we want to swap to, and this is the original images, and this is the final result. Here we can see my face has been totally changed. Let's see more changes in details. The right here we show the right eye and the mouth area of those 3 images. Here we can see the eye and the mouth of the deepfake face is much similar to the target face. Actually, the method we proposed is a real-time algorithm. It can run on a single MacBook Pro. Besides, this method only requires one photo of the target face rather than hundreds of images like other methods. It is running low cost and effective. Except for deepfake audio videos, deepfake technologies have generalized to the audios. Okay, let's listen to those two audios from Tyler and Obama, respectively.
Hello, everyone. This is Taylor. Welcome to Cancer Quest 2020.
Hello, everyone. This is Obama. Welcome to Cancer Quest 2020.
I think you guys have guessed those two audios are fake. Yes, they are the fake audios. I use only a few pieces of the target voice records to generate them. It proves that words are easily to be mimicked as well. So, how to deepfake an audio? Actually, it only needs a few steps. First, we use a speak encoder to capture the representations of the characteristics of the target's voice. That is the voice we want to mimic. And then we use a text encoder to convert a character sequence into a hidden feature representations. After that, we concat the representations of the target words and the representations of the text sequence. We could generate male spectrograms. Finally, we use a vocoder to embed the synthesized male spectrograms emitted by the synthesis network into time domain waveforms. That is the final generated fake audios. And at the end of this section, I am willing to share two real-world text cases using deepfake. The first case is bypassing face anti-proofing. This figure shows the whole process of this kind of attack. Giving a photo of a target person, attackers can use the deepfake technologies to swap the target face to the source image. And then send it to a 3D modeling tool to create facial actions required by the face anti-proofing, such as open mouth, winking, and some other facial actions. After that, they inject those fake videos into the phone camera to bypass the face anti-proofing. The second case is IP phone scam attack. When we are calling, attackers can use the vulnerabilities in the IP phone protocol to tamper with the phone's voice data. This attack is nothing new. But with deepfake, attacks can utilize voice data to deepfake the voice of attack targets, make the target to see what they want he or she to see, and then inject the generated fake videos, fake voice data to the phone and to achieve the purpose to scam. So how to defend such deepfake attacks? In fact, they'll have a lot of challenges to achieve that. The first is they'll have imagined various deepfake technicals such as face swap deepfake, face-to-face, cyclogram, and many others. And to be honest, in many cases, I think it's very difficult for human eyes to identify which video is fake or it is all a real one. Besides it is also challenges other face-related algorithms such as face detection algorithm, because to determine a face whether it's a fake face, we should detect the face first. And lack of the carefully labeled data set is also a significant problem as well. In fact, there already have some data sets such as face forensics and the FDC, but the deepfake technicals to generate those data sets are limited, and their labels are rough. For example, the FDC gives a single label to a video, fake or real. But for fake video, some frames of it are real, but the others are fake. And now, deepfake technologies is rapidly developing. It will be more and more realistic. Therefore, it is still a hard problem for both the academy and the industry. Technology has given us deepfakes, but might it also provide us with a capacity for debunking them and limiting their harmful potential? I think the answer is yes. And we also try to prevent the risk of deepfake abuse. We developed a framework of deepfake detection named anti-fakes. It consists of 3 fake detection modules: local face classification, resolution analysis, and global detection respectively, and a celebrity recognition modules. This frames takes an image in or a video in, and then outputs the fake detection results, including the coordinates of all detected faces, their labels, fake or real, and corresponding confidence, as this figure shows. Let's see more detail. The first module is local face classification. This step takes an image in and detects all faces using face detection algorithms at first. And then we crop all detected faces and send them one by one to face classification network to determine whether the face is fake. This is a fundamental method to solve the fake challenge. It takes use of the local features of each face to detect the fake face. There are different classification networks we can choose, such as exception, ResNet, and some other classification networks. And the resolution differences between the fake face and its surrounding area is a major characteristic of the fake, so that we add a resolution analysis to anti-fakes to take use of this feature. This module first calculates the values of each detected face and the cells around it. After that, it calculates the ratio of those two values. If the ratio is smaller than a threshold, we will consider it is a fake face. Otherwise, it is a real one. The last fake detection module is global detection, which based on detection networks. This module feeds the image into a detection network to automatically detect fake faces. Detection networks are good at capturing features of the differences between the foreground and the background. So we utilize it to extract the global features of the hero images to detect the fake faces. After above 3 fake detection modules, if a face is definitely to be considered as a fake face, we will send it to the celebrity recognition module to confirm whether it uses a celebrity face. The purpose of this step is to prevent the using of deepfake to create political crisis. This module cropped the detected the face from the original images and then use a face feature extractor to get the face feature vectors, and then calculate the distance between between this feature vector and the feature vector of each celebrity face in the database. If the distance is smaller than a threshold, we will consider it uses a celebrity face. Those two videos show the detection result. The left one is the original video, and the right one is deepfake video. The girl in the right video is detected as a fake face, but not a celebrity. And the boy is a real one. You know, the deepfake technology is developing really rapidly. To be honest, anti-fake still has a long way to go, and we are still working hard on investigating better solutions to defend against the AI abuse. At the end of this talk, I want to share a little story about how we use AI to try some good things. This story is about the elderly. We found that there are about 40 million elderly fall in China every year, and typically the golden rescue time within 5 minutes after a fall. But because of living alone, missing the golden rescue time after a fall is currently the main cause of the casualties for the elderly over 65 in China. So that we developed a fall detection system based on TOF that use AI algorithms to detect whether someone falls. Once the system detects a fall, it will notify relevant person to come and help. To test the robustness of this system, our test engineers try various fall postures every day. Those funny pictures are really portraits. Tech for good is a key principle in our company. As an engineer closely related to AI, I am always purposed to doing something meaningful with AI and tech for good and AI for good. Okay, let me make a conclusion of this talk. AI is around us every day, but the security of it is still one of the biggest challenges, including software and hardware security, robustness of AI models, and some other security problems. In each process of deploying AI systems, corresponding differences are required. Besides, the risk of AI abuse cannot be ignored, especially deepfake technologies. But unfortunately, there is still a long way to go to prevent the abuse of AI and defend against deepfake attacks. So what should we do? Of course, our ultimate goal is to build a secure and trustworthy AI systems and use technologies to avoid AI abuse, and the most importantly, AI for good. This year is really a crazy year for us. Various spreads through the whole world, and we cannot meet together as before.
Test. Oops.
Okay. Okay, that's all. Thank you. Feel free to ask questions by sending emails to this address, and especially thanks to Pussy, Zenos, and Dragos. Thank you all. Thank you all guys working for support this conference. Thank you.
Okay, so here let's cut to that slide again and give our sponsors some airtime. Thank you very much for all the folks who sponsored CanSec West. And that is about it for the first time I stream. We had some problems with one of the streams, so we're going to re-upload a version of this talk to the SecWestNet YouTube page because I was busy futzing around at the beginning of it. We just finished setting up that channel for the first time, so we're still getting all the kinks out of the setup. So I'll wish you all a good night, and we'll see you. We'll see you Wednesday night, hopefully next week, where we're supposed to be doing these regular broadcasts. We'll be announcing on around Monday or Tuesday what the broadcast is for next week. So until then, I will see you